All right, on this next page, we've got some that are going to deal with multiple bonds. So let's try to figure out how to deal with that. So first one here, O2, oxygen. There are two of them. Would love to have 8 valence electrons. So that's going to give us 16 valence electrons in an ideal world. There's still 2 oxygens. However, oxygen is blessed with only 6 valence electrons. So that's going to give us 12. Our difference, 16 minus 12, will give us 4. 4 divided by 2 will tell us that there are 2 bonds between them. So let's just draw them. We've got our 2 oxygens. Let's put 2 bonds between them. And now let's give everything a full complement of 8 electrons to make it all happy. Take a look at number 2. Very similar. We've got N2. 2 nitrogens. Would love to have 8 valence electrons for a total of, can't multiply there, sorry, total of 16. But nitrogen's in group 15, so it actually has 5 valence electrons, so we're going to have 10. Our difference will tell us that there's got to be 6 electrons shared between bonds. 2 electrons per bonds, that gives us 3 bonds. So we have a nitrogen and another nitrogen with 3 bonds between it. Each one of these nitrogens is going to need 2 electrons to fill up its outer shell to give it a total of 8. So we've got 2, 4, 6, 7, 8. So that makes them happy. Let's take a look at, skip ahead to number 3. Not really skipping ahead there, but there are 1 carbons, or there is 1 carbon. Carbon would love to have 8 valence electrons. There are 2 oxygens. Oxygen would love to have 8, so this is going to give us a total of 24. Still 1 carbon. Carbon actually has 4 valence electrons because it's in group 14. There's still 2 oxygens. Oxygen actually has 6 valence electrons because it's in group 16. So 6 times 2 is 12, plus 4 is going to give us 16. Do the math here. This will give us 8 valence electrons that have to be shared. So for a total of 4 bonds. So what's this going to look like? We've got our carbon in the middle, and oxygen on either side, and a single bond connecting them all. But we need 4 bonds. There's only 2 here, so let's just throw another pair of bonds in. Now let's go around making sure everything is happy. So our oxygens definitely are not happy. They need a total of 8 electrons. There's 2 from each bond. So 2, 4, now we got to have 5, 6, 7, 8. And then same with this oxygen over here. But the carbon's happy because it has 2 from each bond. 4 bonds gives it 8 valence electrons. Cool, so that's going to make oxygen happy. Excuse me. And then let's take a look at N2F2. A little bit different here. We've got multiples of 2 elements. So we're going to look at nitrogen. There's 2 of them. Love to have 8. And there's fluorine. There's 2 of them. They would love to have 8. So that's going to give us 32 electrons. Nitrogen's in group 15. There's still 2 of them. Oops, sorry. Alright, so where was I? Sorry about that. So we had nitrogen. Nitrogen's in group 15, so 2 times 5. And then there's still 2 fluorines. Fluorine's in group 17, so 10 plus 14 is going to give us 24. 32 minus 24, that's going to give us 8. 8 divided by 2, that'll give us 4 bonds. So we're going to end up with 4 bonds here. So let's put our fluorine, our nitrogen, and another fluorine. Fluorine group 17 elements generally like to be on the outside of things, only with 1 bond. But let's put all the bonds in here. So now we've got 3 of our 4. So where are we going to put our 4th one? Let's put them between the nitrogens here. So let's go make everything happy. We need 6 electrons for each of the fluorines. And then 2 more for each of the nitrogens. And that's how it would look. Let's try, let's see. Let's try this HCN. Well, let's try H2O, CH2O here. So carbon, there's 1 of them times 8 plus 2 times 2 plus 1 times 8. That's going to give us, that's 16 plus 4 is going to give us 20. 1 carbon, group 14. 2 hydrogens, group 1. 1 oxygen, group 16. So that's going to give us 12. So that's going to give us 8 bonds. Divide that by 2. And we're going to end up with, 8 shared electrons, 4 bonds. Carbon's going to be the center. Put a hydrogen around each side, and then we're going to have an oxygen. Single bond to everything. Now we need 1 more bond, and we know it can't go to the hydrogens because that would give them too many electrons, so we're going to put it down here to the double bond to the oxygen. Fill up everything's outermost shell. That's going to make our oxygen look like that, and our hydrogens like that, and our carbon like that. So we're done.